I will start with why this machine learning or learning at all is important in the Internet of Things. God, nowadays, everyone, every industry, a lot of things are going on, and everyone in the whole world is talking about the use of AI and machine learning in different applications. And whenever this application comes out, IoT is one of the platform you can say where we can connect and make the things smart. So let's to begin with. Just to begin with, what is IoT? Already it has been covered, but yet again, just quickly I will revise those things. There are a lot of things, and through internet, either we want to connect a physical human being, we want to connect animal, human being, digital machine, devices. We want to interrelate where seamlessly the data could be flow from one point to other, either from human or from one device to other. We want to be a connection, a physical system where different devices, different participant, human, animals, any physical industry, aeroplane, everyone can connect. So this IoT applications at the first hand is coming like that, the connecting the different products you can say, and huge industrial applications. If you are familiar about the vending machines or a coffee machine, which you can say, and a different way this coffee machine can work. For example, using the IoT, we can put the machine that and timer where human also intervenes for some time. Either it may be a fully automatic or sometimes human may come in between to play the role in the different applications. So you may think about like sometimes just the connection and no smartness. Only thing is that the things we are going to connect on one platform, and then there will be a human being, and that human being on the basis of those informations are coming at the place, they will took a decision what needs to be done. So for example, I am talking about a coffee machine. A coffee machine, we can make a program like that, okay? Every day, like 7 a.m. I am waking up, and then once I wake up, I will fix a rigid program. Coffee machine right now I'm talking about. I will fix a program, okay? At 7:15, you just start preparing my coffee automatically. That maybe I can put it the timer, and the timer will be connected to the machine, and then automatically it will start and doing the work. But it is not smart. But it may be one IoT applications where things you have connected the timing part and your machine. Once the clock will be at that level, your machine will start working, and after that, you will get your coffee for this. So this is a very, very important part, and many applications are that. So later on, you can think about a different IoT smart framework also, where these appliances are connected on this platform. Or just forget about the sensor measuring and all the applications. Later on, people have talked about making the smart IoT applications. I will connect this smartness on through this IoT application. We want to make this one as a smart. And so the one thing is that if this one was not here, if you already we are seeing from the last 10, 15 years, a lot of machines are building machines are there. And they are working. You just do some kind of manual work, and after that, some automations were there. So after that, people think that why not we can put some sensors. Then sensor will pass runtime the information at this smart IoT smart platform. Data will come up. So this one is the one development through sensors we are getting the data sets in the different applications. Still, Now in the last 2-3 years, AI and machine learning, we are talking about the application. But before that, people were measuring and manually, then people were doing some decisions and taking a decision. Taking the, for example, sensors, we can, in the same coffee mug example, what we can think, okay, without AI and machine learning right now, I'm giving the example, we can put a camera, and without pressing that, on the washing machine, we can put one camera, and then once that camera will see the person is there, that your face is already, suppose it has been fixed on the machine. You will read that your face and see that, okay, it means you have been wake up from the bed. Then after that, you can make a timer that after 15 minutes you start processing. So again, through sensors of the earth with this camera, it has been captured. You have not manually set the time. Already I have wake up and do this. Once that will see the your face, and then coffee machine will start preparing automatically, and after 15 minutes or something, the coffee will be ready. This one was without AI and machine learning, but still people have developed this form. Okay, and something has been developed for the application purpose, because this IoT is giving a lot of breakthrough and application basically in the different domain. Then later off, then after that, this machine learning comes out in the same application. The idea was, okay, you just suppose you think about the same coffee machine problem. Think about just wearing the smart watch, and you can go for the sleep. And through that, your watch will see the every pattern. Just the IoT and things are coming. Everything is going to be connected through your platform, and your machine is also going to be your washing. This coffee machine is also connected to that platform. Just see how this can be happen. The data will be through this. They will measure that already you wake up or not, and suddenly signal will be go to the smart platform, and to that platform it will be for that, okay, the signal has come, then send a signal to the this copy maker machine, and that machine will then start, after some times, whatever the time lag, you will fix that, it will start preparation of coffee. But what the machine learning will do in this case, okay, this machine learning say that, okay, a lot of your sleep pattern, your wake up style, you will observe, and then you will learn that when actually you are going to wake up. Maybe in the only wake up is important, and you just come up in the midnight for water. It may not be like that. You just start preparing, because already you have fixed that. Once you wake up and walk, you start preparing coffee. So what machine learning will help, collect the data from your last 1 month pattern. You need a data oil in the machine learning, and based on the data, then it will predict, okay, what is the actual wake up scenario, and then only this machine learning will learn that point, and it will send the signal. So the anomaly that happened, that during the midnight or sometimes you wake up for any other purpose, and it should not be the signal that, okay, already trained up, send the signal to the cloud, and then start preparing this coffee. So machine learning in that part, even in the business, is helpful to know the actual scenario from the data, just interpretability and learning of the data, and the actual case, then machine learning model will be able to help improve the decision-making process and automation. And that's how this AI and machine learning you can think about in the application, especially IoT-based application that is coming in huge way. This machine learning means learning and playing with the data to, instead of doing by the human, to here putting a human, automatically looking at the data and take the decision. And then you just start sending the signal to the all the equipments which are connected for the specific task based on the database and machine learning predictions. I'll give 1 or 2 more examples where a lot of industries are working currently. So you may think about, because nowadays many startups and many things people are proposing for IoT, and everyone wants to make this smart IoT. And how it makes IoT smart, that's what the machine learning and AI are coming play to make this AI platforms and AI application as a smart system. It may be one application will be like home appliance insurance. What is there? Because every time in the insurance business, even it is application for the human health also, maybe I'm not thinking, but some industry people will make a device. If you are buying any human insurance also, it will connect some kind of sensor or watch to you, and then they will connect your seat, or maybe might be from your smartwatch. They are taking the information from that company that okay, what kind of health level you have. Accordingly, they will increase the price and they will issue insurance. Same times in the business sense, this one is a huge way applicable. In the business sense, you can think about insurance for any product. Any product, if I'm saying either it's a refrigerator and you put in the one sensor and sensor will monitor the health. Okay, designing the sensor for that part is another domain where people are working a lot of hard work on that. And that signal will go to the exact those who are giving the insurance, and then accordingly some machine learning algorithm they will put in the decision, okay, what kind of usage, how you are handling and using that equipment. Accordingly, they will gather the data and predict that, okay, what will be the durability of working of your machine, and accordingly this insurance will come. Huge application in manufacturing industry, huge way all the automations are coming in the manufacturing. You just see this picture diagram which I have put at that, where things are connected to each other. Many products and lines are earlier at each industry, a lot of humans were there at the every level to see that what is going on, or any anomaly is coming in the product or not. And then based on the sampling, they used to take a decision. The automation has helped a lot in that way that, okay, historical data you collect, put a machine learning algorithm on that, and then you will detect the anomaly, and then quickly you analyze those anomaly, and then next action will be initiated instead of waiting for the human, which may cause some kind of error in the decision making. The hardcore machine learnings or AI are helping in the day-to-day activity monitoring and maintenance of the industry in a huge way. Though costs are involved putting sensor and every machine learning framework and tool, but since industry are getting a lot of benefit of this, so they are doing it. A lot of IoT based agricultural applications are coming. People are putting a drones for the monitoring and doing that. So in that case, also after this, doing that, those data can be used using machine learning algorithm to learn and infer something meaningful in that. Supply chain is huge in India. It's very less, but huge way it is coming that IoT based supply chain management quickly as per need at the different location of the country, what are going to be shortage or demanded, then the flow of the material from one place to other in an optimized way, in automatic manner is also a huge application. Security, many people are proposing new things, and health monitoring system. After COVID-19, even before that, people have started. One of the huge applications it will be, we will see in the next 5 years, even in India, this health monitoring system. What is that? One thing is that something is happening manually. Suppose one accident happened, and if you are wearing some devices, based on the impact, the message will be sent to the ambulance or nearby ambulance, and then the location will be shared with that ambulance person, and that ambulance will come to your door, and then doctor may come with that, and the treatment will happen. Such kind of huge application of health sector is next 5 years is going to see this AI. Apart from that, many your our individual health monitoring system also we can every time we can monitor while the using different kind of devices, biomedical devices are coming, people are proposing. Though based on the IoT applications, it will be very soon, it will capture the information of our individual health, and then alarming signal something will happen, your BP is increasing or cholesterol is increasing if the device is up. And so after down the line, they will suggest what needs to be done by you, what is not should be done by you. So that kind of suggestion and automatic, either manual it will be do or the learning will happen to the AI and machine learning. So AI and machine learnings are also very helpful in that application. Recently, I was in Fujitsu lab in Tokyo, and just one example I will share with you, one more, and what they are planning for next 10 years. You just think about what kind of IoT based system they have imagined and they have planned to make available by 2030 in Japan. What they have planned, if two-person wants to meet, just why you are not going to tell me and any one participant looking at the mail exchange and message, machine will automatically read that, okay, let you both are going to meet at Delhi. Once it will be read and you want to meet in Delhi, then okay, after that, the signal you already fixed date, suppose today 12th October, we want to meet in Delhi, then signal will be passed to the, automatically that signal with the travel agency. Travel agency will book your as per date for your traveling ticket. All are going to happen automatic. Then at the same time, hotel requirement, once when you reach what time you need a hotel requirement will be automatically booked. Then after some time, what will happen? The location of the meeting, that will also be automatically fixed. Looking at the time, you both want to save your time, it will be done in that way. Once you both will be on the way of travel by car or local traveling, even what they were thinking that, okay, in Delhi, maybe at the Connaught Place or somewhere, if this is the common place, that vehicle will meet in between and both person will sit in the car now, in the common car. And then from that common car, they will start discussing and all. They will reach to the restaurant. Meeting is going on now. You want to meet and meeting is happening in the car. You will reach at the restaurant. There also you will meet automatically for both of you. The menu will come up. Instead of menu, all the choices, the dishes will be directly served to you. Looking at the historical data, the menu will be served to you. You will just eat. Your meeting work will be done. A lot of time will be saved. And after that, looking once work will be completed, discussion will happen. Again, you will leave. When you are going to leave, local travel will come accordingly for your return tickets and all. You think about it. On day-to-day life, as a human, we are just plan that, book a ticket from here to Delhi, then book a one hotel, then you book a meeting point, we need a common place, then what every time the menu comes out and then we'll get that, okay, this item I want to eat, that item I want to eat, and then again I have to return same thing. Is it possible everything will be automatic? Based on your mobile data or something, only that, looking at the historical pattern, what the Fujitsu Lab have planned down the line 2030, they want to make available such system in Japan. And they're working for that. So a lot of IoT applications, a lot of machine learning, because huge data is every time, a lot of NLP, natural language processing, computer vision, and a lot of tasks are happening inside. And automatic development of such system, if it take place, just imagine what will be the next. So what I'm trying to say, this AI and machine learning with a lot of thinking of IoT, a lot of infrastructure availability in the current era. Now people are talking about the 5G, so a lot of internet connectivity, infrastructure. People are thinking to make everything like someone is there to planning you, no PA. That will plan everything and will be done, and you will do all your activity regularly. So huge application in the machine learning in that way, in such a kind of smart applications are coming. This is the new in the applications or incubation kind of industry, because everyone, those who are going to incubate are thinking to make profitable business. It's not like that non-profitable. And for that, they have to think, okay, this one cost for the infrastructure level and what kind of learning are important or will be helpful. That if once we have a plan, we can just develop and all these things and we can work with that. What is the role of machine learning? I'm coming in more detail now because this one more focusing apart from the example is that in the IoT, we want to make a smart IoT. IoT earlier was without machine learning, IoT was just connected of different devices in one platform and then took a decision or rule based, write it there for the sending a message from one to other one. What machine learning is that, okay, can instead of human intervention every time, is it possible that the data sets are coming and then machine learning model will automatically learn those data and do the fruitful things? So what is important here comes out to be quite valuable for accurately prediction future event. And there are so many application vision to NLP machine learning models have shown that ability to predict the future, what is going to be happen, it's either regression application or in the classification application or many more complicated tasks, it has been shown. So this one is able to make the smart. Another one is you can think the predictive capabilities of ML are extremely useful in industrial setting. What I said that in the application, people are putting a lot of AI and machine learning in manufacturing industry. So the reason is that the huge data they have, and manually instead of putting some expert, these from the data, this machine learning models are able to get that when this machine needs repairing, when going to be happening the fault. So before going to be fault occurred, if we know in beforehand, then maintenance will happen. So machine learning is saving because stopping time is more dangerous. If something is in product line, company is going to stop for 2 days. Better than that, instead of closing for 2 days, if 10 minutes every day and I will do the repairing, maintenance work, and it will continually then continue, my industry will work. So the huge way this predictive power has given the huge success in that case, and that's why this machine learning in IoT is one of the important work in that. Another, for example, is Nest thermostat. One industry, what I just put it in, uses ML to learn how hot or cool we like our homes to be. How you like that, and accordingly ensure that the house is at the right temperature when we get home from work. This kind of IoT application, a lot of people are making smart houses and all. But in that case, also MLs are helpful in the learning from the data. Each individual have different kind of liking. Someone wants always to be at the 20 degrees Celsius and someone says that 28 is okay. So each individual behavior is different. Pattern is different. So learning each individual pattern behavior, we need ML algorithms or AI to make IoT application as a smart application. In any IoT situation, what others part is that to help different companies take the billions of data points that they have and they distill these down to whatever is really meaningful to them. So what is there? So from different data sets, either everyone is collecting what Amazon is doing, what Flipkart is doing, what Netflix is doing. Everyone is collecting data, and they're not putting a data. They might be, they can selling the data for other also. What the data Amazon and Flipkart is collecting, they are predicting the same kind of pattern what you are going to buy at the next level. So though every information they're not putting sensor at this level, but they are putting that okay, manually your searching pattern, what you are seeing, they are observing through ML. They are because they are not putting machine learning human being for each individual. They are putting machine learning models to read each individual pattern, and accordingly you suggest them what next he or she is going to buy. We all are at least witnessing this application on Flipkart and Amazon. Same way you can think about different applications of ML and AI in IoT, different kind of applications, same kind of suggestion, same kind of future prediction in different other either health or industrial applications. So ML is very important to make IoT application as a smart application. So let coming to the machine learning model, which I'm going to talk more for just 1 minute. I'll take water. Okay, so I'll talk about some machine learning stuff. A lot of thing is that why it has been, why this stuff is needed in the IoT part. What is, let's start about the learning. What is the machine learning? And the learning is a process by which a system improves performance. It's learning is happening. So from one process to other. So our the same thing, same kind of work we are repeating, our performance should be improved. Then we can measure that, okay, learning is happening. Especially, we all are learning. Either we personally or we all are observing every childhood, every kid, how they are learning. Just see the one. Okay. This image I have put it deliberately. The one kid and another robot. We all are talking about machine learning. We are talking about the learning of this robot. How this he is going to be automatically learn and do. The reverse question, if I ask, we all have gone through this phase. How we have learned and how we are learning to. This time also we all are learning each time something. How we are learning? What is the way? Different way we are learning. It is very, very important. And the same way this learning we are going to use in the different machine learning models also. Though these machine learning models are not capable as intelligent, think out of the box as human being right now, but we don't know in future. That's it. It may be like the movie I, Robot, which most of the people have seen. The robot may do all the activities, but still it's far away. People are working on that. So what I'm talking about, the machine learning is that a program is set to learn from the experience E with respect to some class of task T. The class is important. The task is important. What we are saying in the examination or something in the teaching purpose, the task is fixed. If someone is a math course and someone is teaching the mathematics, so the test should be on the maths performance, not on the history performance. So the measurement should be based on this task performance measure P, how your performance is. If its performance at task in T as measured by P improves with experience C, or as the data increase, if the experience or accuracy or working things are improving, then we can say the machine is learning. This one is machine is learning. Basically, this one is somehow up to a certain extent valid for the human being. So the learning, machine learning, a lot of so many algorithms are that I will talk about. Let's come to the machine learning, the basic developments of how it has been developed and category of the machine learning models. From the especially from perceptron and other from last 60, 70 years and last 20, 30 years, huge applications we are seeing. So let's start with what is machine learning. So a different category of machine learning are one of the machine learning first we can say category is supervised learning. It's similar to what we are doing in the classroom teaching or what you have observed what the teachers do in the classroom teaching, where labeled data are available. Labeled data sets are available means sometimes teacher told you that this one is wrong or right. So labeled data sets are available. In that case, we do the supervised learning. So most of the time, you can say the classroom teaching as example is a supervised learning, where the questions what we are asking, also we know that the answer, we tell them, okay, this one is correct or not. So some kind of things where the similarity we can see in the classroom teaching is supervised kind of learning most of the time. And within that, supervised learning also can be categorized as a classification test technique also. So if you want to make a classification, either cat or dog, or either anomaly or normal behavior, in that case, supervised learning case, it comes out the classification problem in the supervised learning. Either it may be image or fraud detection or diagnostic. A lot of technique in that case, either support vector machine you can apply in this, and an artificial neural network also can be designed for the supervised learning task. Also some other technique, logistic regression also we can apply in supervised learning task. What happened in the regression? What is the difference between classification and regression? Both have the labeled information. Data sets are labeled in both category, but the difference is that in the classification problem, labels are discrete, and in the regression case, labels are continuous. Any value is possible in the label, then it's a regression problem, and a fixed class are possible, either 0, 1 kind of a class or 0, 1, 2 discrete values are possible only, then it becomes classification problem. So regression problem nowadays, you can say weather forecasting, share market forecasting, many kind of estimating life expectancy, all are comes out within the regression category. So in this case, regression methods are available. Even support vector regressions are available, which you can use in this case to solve the problem. One, two, three techniques I am going to discuss in the coming slides in detail. Then another class of machine learning problems are unsupervised learning. Like unsupervised learning is in the, if you know, Eklavya, and he did just draw a statue, and after that, without getting any knowledge from Prachar, he just learned this techniques. The same way in the unsupervised, no labeled data. We all have in our mobile phone so much images, but most of the images are unlabeled. Unlabeled means except you, if you can give those data sets to someone else, he or she cannot recognize who is. You know that he is my father, he is my brother, or like that. But others, until unless you label that, people may not know that. But for them, it's another human being. So unsupervised learning, huge unsupervised data are available. In the case of supervised learning, we need some expert or annotation of the data will tell that what's the label for this data sets. Unsupervised data, any data you can take without label, it's unsupervised learning. And this region, the such kind of data, huge way available in a different dimension. And so for that, in unsupervised learning, also some techniques, either K-mean techniques comes out within that category, or in the end, so many techniques are comes out, and in that case, also some deep learning models are available, which I am not going to touch in today. And in my talk, the next talk, Professor Verma will cover that. So in unsupervised, also what we do, compression of the data sets, structure discovery, what kind of structure or patterns are there, but without knowing the exact level. We just do the feature engineering also, even though feature engineering supervised data also are important. Dimensionality reduction, such kind of techniques, most of the time we do in the unsupervised learning task. And also some clustering techniques are there, recommendation system, customer segmentation, targeted marketing. So what I gave some examples where the unsupervised, if data sets are available, then how we can do that. So K-mean, another clustering, algorithmic clustering, and so many others are available. So it comes out in the unsupervised learning category. Another kind of machine learning algorithms are reinforcement learning, and especially this class of machine learning algorithms are useful in the real-time decision, robot navigation. So what is happening in robot navigation is, so one path the robot is taking, then again feedback will be given to the system, and again he will take the next step. It's a feedback based, you can say. So some reinforcement, that knowledge to the back to the system, and again the next direction will be decided. So many game designing, skill acquisition, learning tasks. So reinforcement learning is another kind of, if we can categorize in the machine learning in this broader domain of reinforcement learning. So what the idea is, in the based on the need, what kind of work we want to do, accordingly the techniques we have to adopt. There is no ready-made that always you go with that. So for different kind of problem, even in the IoT based applications, we have to look at what kind of data we are getting, what is our target to achieve, and accordingly to choose the learning objective and getting a solution for that. So these are the broader skeleton, you can say, different category in the case of machine learning models. Going ahead. So I will talk about now this feature engineering. If you see this again, the picture, regularly I am putting that so that we can see why we need such kind of things in IoT applications. So data acquisition is one of the important part in the IoT applications. A lot of things, a lot of product, vehicle, mobile, house, everything is connected through this. And so data we are gathering, a lot of data from the different source. Everyone is sending the data, and everyone have a different format also to give. So another challenge comes out in the terms of format. collecting of the data, what kind of data, how this data will be received and represented for the learning. Okay. Then digital signal processing, different kind of signals are coming, so that also the processings are important. Next important part is feature engineering. So feature engineering, just detail next slide, one more slide I will discuss, is basically the data sets are coming in huge dimension. But for the machine learning task, the features are important. How the data should be represented so that our learning will be happen the better way. Is that any random way you put a data sets and you will get a better learning? Most of the time, machine learning models may not be able to get a better kind of interpretation and knowledge prediction if our representation feature engineering is poor. So feature engineering, getting that the feature and representation, what should be the data represented, how the data should be represented from the raw data, what kind of next level representation, proper representation of data should be. That's what we talk about in the feature engineering part. It is required basically for a statistical inferencing as well as in the machine learning to get better prediction. If this machine learning have a most of the time poor performance if our features are poorly represented. So this feature engineering is very important part to get this machine learning to work better way for your particular application. So in that case, either diagnostic and that way, okay. So this prediction is wrong and wrong interpretation, so it will be impacted huge way in your application purpose. So make this machine learning and AI to get better learning and predictions. The features are very important. There are so many techniques for that. Appearance based, feature based, either template based approach, but so like one is principal component analysis, and there are LDA, ICA. So there are so many techniques. One quickly I will talk about, and then features, giver features. You just convert what kind of features are there, either binary feature, binary pattern you want to choose from the data, or gather features to represent and get the data set feature, this feature, and then use in the machine learning and AI. What PCA do, principal component idea of principal component analysis is, this one is one of the feature select extraction technique. There are two kind of, suppose there is a problem of 10 dimension data sets and you want to do the classification of that. So in this case, feature selection is what? Out of 10, select important features, maybe 2 important or 3 important, that will act the better way in your learning. Instead of using 10 dimension, if there are 2 features only which do the job to be done easily. But what feature extraction is? We want 2 feature extraction, but out of 10 feature extraction is using those 10, create 2 new features which are going to represent those 10 features in the approximately closely to that. Selection, you just pick any 2 based on the performance, but the extraction is using those 10, you may get any 2 new or 3 new. This is what is extraction. And principal component analysis is basically one of the important feature extractions technique in the machine learning era. Later on, autoencoders and all has been come up also in the deep learning part for the feature extraction as a feature extractor also, though autoencoder I may not touch. PCA job is to extract features for that, and this PCA is nothing else but based on the eigenvalues and eigenvector. What it says philosophically, any matrix or data sets in the matrix form is available, find out the eigenvalues, then take the largest eigenvalue, and then corresponding to largest eigenvalue, you have a largest eigenvector. Okay. So what is the idea? The whole data sets you map corresponding to the largest eigenvector. Vector, so any vector is one direction. So project all data towards the largest eigenvector. So that will be one feature. Project all data corresponding to the second largest eigenvector. This will be your second principal component direction. So this way, that from using this eigenvector concept, this PCA was developed, and it was a huge success in this, especially in the PC and ML. So there are so many feature extraction techniques. I may not go for each individual one, but what idea is the feature extractions are also important for the performance of this machine learning algorithm. So quickly, I will talk about in this lecture the starting point. We start with the perceptron, then I will talk support vector, and then multilayer ANN perceptron. Quickly, I will not go each and every detail in 1 hour. It may not be time. How we can use this, I will discuss after this. The perceptron was the basic, you can say, the starting point. And what is perceptron? It is nothing else but the plain equation. What if you simplify this, what will happen? This is nothing else but W naught plus W1 x1. You check summation. Summation means W naught plus W1 x1 plus W2 x2 plus Wm xn. What is this? It's an equation of a plane. So what perceptron is? Summation of, oh, sorry, it's less visible. This one is summation of Wi xi. Same thing I am saying, Wi xi. This summation means Wi xi. What perceptron concept is, if you want to classify two things, cat and dog. So you start with a plane. This one is the equation of a plane, though represented as a network, but this one is a equation of a plane. Linear plane, you can say, is a linear one, perceptron. What was the idea in the perceptron concept is, suppose if you want to create any line between images of cat and dog, so that we can classify this above this plane is a cat and this one is a dog. In that case, what a hyperplane is there, this W naught x1 is randomly start with any hyperplane and repeat this process. Each data set you pass to this one, this threshold. You just put W1 x1. So for each data sets you pass, if the cat is correctly classified, then don't change the plane equation. If cat is wrongly classified, then you change the plane. So if in this board you can think about, one, this part I am saying that let cat, and this one is D. Right. So starting line may be like this. So the cat is, and let this part is for cat and this part is for dog. So what perceptron is saying, change the weight next time. Next time like this. Next time like this. So you change the weight till all your data sets are not going to be correctly classified. So this way this perceptron was developed. The first time, but many drawbacks, pro and cons was there for this. But this one is the starting point of development of perceptron learning. You start with a hyperplane, then based on the data sets in each feature, look at is it correctly classified or not. If yes, then okay, go to the next data. If not correctly classified, you change the hyperplane equation, go for again, and just repeat the process for all data till you will get the accuracy. That's what the perceptron learning. It was good, but there were limitations that if your data sets was linearly separable. Linearly separable means for data sets, if the line is possible, which can clearly classify it, it was working fine. But for non-linear classification for kind of data, this perceptron was failed. So for the linear classification, this simple weight plane randomness was sufficient to classify. So then later on, people feel that, okay, we need some non-linear kind of classification also. Just 1 minute. Okay. So going back to this, then later on, this I'm showing you how the development was happened. This one is the perceptron is also one algorithm which you can think about a simple equation. If the data is just classify a linear kind of data separable is possible, you must play. Later on, people say that, okay, this one was advent of support vector machine. The same problem, if you look at in the terms of perceptron, what perceptron idea was that if you look at this problem, the red ball and green ball separation, the perceptron idea was to separate this line and then manipulate. And if you see that this one is a linear separable, even though SVM is applicable for non-linearly separable cases also. But think about right now looking at this picture for the linear separable. If the data set is linearly separable, what perceptron theory say, there is a guarantee that you can, through this perceptron, you will get that plane. What is this idea is that you start with this and perceptron, repeat the process, and finally you will maybe get this. But later on people say that, okay, and the perceptron theory concept, okay, can we draw a plane which have the maximum margin? This one is that, if in this case, if you see, if there is a one line is possible, then there are infinite lines are possible. Many lines we can plot in this support vector machine. So that later on, what people say, okay, can we put a margin concept? Margin means this distance from hyperplane, this plane to this one. This distance is the margin. Basically, this one is the margin. So can we put this concept? Since perceptron theory is saying if there is one possible, so infinite possible hyperplane is possible. Can we choose on those infinite possible hyperplane? Can we choose a single hyperplane which can give the maximum margin? Maximum margin means a hyperplane from which this class the first element and this class first element have equal distance. Okay, it should not be like this and it should not be towards this. This hyperplane neither close to this, neither close to that, so that there will be enough gap from this hyperplane and this class first element and this class first element. So only you can think about as addition on that was that with perceptron, okay, the plane equation Ws plus B, same plane equation what used in the perceptron, but another concept was added there with the maximum margin. Find out the plane which gives the maximum margin in the data sets, and that's what the support vector machine derivation part I am not going. This is Wx plus B means this is one class, and what we do for one class red point we can say +1, for green class we can say -1, and what we want yi is the label +1 and -1, and both objective function is find out the maximum margin with respect to this constant. This constant means each class should be clearly classified, correctly classified. That's what the meaning of this constant. So later on, objective function we can optimize is find out 1/2 norm of W square, where norm of W is basically nothing else but the weights assigned to the hyperplane. This C is nothing else but hyperparameter, which later on I will discuss how to hyperparameter in this case. So SVM was developed. Though mathematical theory optimization, I'm not going you. Those who are interested and want to use in IoT, they may use either scikit-learn or Python, PyTorch, or any platform to play with these algorithms and apply in your application. But that's how it was developed. The only difference, maximum margin was added, and it becomes a huge success. And especially 20, 30 years, it dominates that in a better way. Accuracy in this, especially in the smaller data sets, it has given. Advantages are it works relatively well when there is a clear margin of separation between classes. Even though kernel concepts was also introduced, I'm not touching. Those who might be aware may ask the question, then I will give on that. SVM is more effective in high dimensional space. Also, if there is a high dimensional space data, also using PCA, somehow we can reduce the dimension also. And then after that, we can play with support vector machine to work fine. And SVM is effective in cases where the number of dimension is greater than the number of samples. Sometimes what happens, too much features but less data. So you can say the fatty features are 100 and only I have a 50 data or 60 data. Somehow it performs well, or if not, then dimension we can reduce using the PCA, and then we can apply in the particular application. Okay, going ahead, moving. Oh, okay. So next development of this was ANN. You all are familiar, we all are familiar, and that. What was that? If you see the perceptron was input and output, only the weights was combined. But what was the limitation of perceptron is that if the linear things are there, perceptron works fine, linearly separable. For the catching the non-linear case, it becomes difficult. If our boundary is like this, sorry, for non-linear case, this perceptron was not working, even though SPM is applicable using kernel concepts. But in the later on, perceptron was extended, you can say, for multi-perceptron, you can say, or artificial neural network, where people say that, okay, to capture the non-linear part, hidden layers were introduced. So hidden layers were just put it here, and then it was better way able to capture the non-linear kind of boundary. May not be a plane, it may be a curve kind of boundary in the data sets. To get that curve representation, this one ANN or multi-layer perceptron was helpful. So what is multi-layer perceptron? In the perceptron, you just introduce the hidden unit also. So this one is the W1, you can say age is representing, this is the input layer X1, X2, X3, you can say this one weight you can say is W1, this one is W2, and again going to be connected at this node. We put the activation function and we convert this activation using activation function at each node value again between 0 to 1 or -1 to 1 based on the application. We can put it and convert. And then again, this one is going to be connected to hidden unit. And then the last, either you put one hidden unit, also it will be a NN, or you can put two hidden unit or many more. And then finally you connect the output. So finally output minus input square, we can say the error function in this case also. What is happening? The hidden layers again as a hyperparameter. Before going to start any NN, we have to put how many hidden layers you want to put in the algorithms. And then at each hidden layer, how many nodes? 2, 3, 4, 10. It's also a kind of hyperparameter. These are the hyperparameter. And the weights W1, W2, W3 are basically the parameters of every model, either in ANN or in the SVM or in any algorithms in the machine learning case. So there are some hyperparameters and parameters. So hyperparameters are these, you can say hidden layers and all. And finally, once the hidden layers are defined, number of nodes on the hidden layers are defined, the output and input are connected as error function, least square method. And then using gradient descents or any other method, optimization technique, the minima of that error function will be found out, and the whole process is to get the best weights W1, W2, which can make one way is that closer to input output or closer to the classification level, whatever the level is available for that. So that's how this SVM works. A lot of theory on the SVM. So this is the overview I am giving right now. So hidden layer and hidden layer 2 or 3 or whatever, and then input and output. So difference between a single perceptron and multi-layer perceptron, now you can visualize. The hidden units have been added in the multi-layer perceptron to capture the non-linearity in the data sets. And that's how the invent of artificial neural network has happened. So if you see in every machine learning models, even in this is valid for deep learning too, what happened? Always we get error function. And the format of error function is we have to minimize E generally expectation or average performance of the classifier. Function what you have learned, this function may be ANN architecture or whatever you can say. Always we learn one function. Support vector machine also with W summation WX plus B, we learn that function. ANN is also a representation of a function. It's a uniform, you know that it's a universal approximation of a function. It can approximate any function. So this is basically a representing a function in the form of network and weight. If you write down W1, X1, W2, X2, it becomes a function. So this function we learn through the data set. X is basically a data. This one from this data we generally learn the function. T is a target. If the target or labeled class of problem is there, T is known. So what is the idea? What the function is giving the output and what already target is there, this error we want to minimize. That's what is the job of machine learning, either perceptron, support vector, ANN, logistic regression. This is the job. And finally, so E is the error function. Minimize this, so this function is optimization function, you can say. And then finally, when we put the R, regularization term. In the machine learning model, we put regularization. The reason behind this, you can understand as what happened in the classroom teaching. Again, every time I used to give this example. In the classroom teaching, not necessary that those who is getting 10 points in each course in each semester is going, this is the semester performance, is really going to solve the real life problem also in the same manner. This is not going to happen. So the idea is those who have been trained and perform well in the training may not be true that also perform better in the testing case. That may not be true. Always 10 pointer is going to solve all the word problem is not true. Chances are high, agree, but not necessarily that those who are good in the training also be good at the testing. What machine learning is saying, the difference you can say is that we need a generalization power. Means algorithm, or in the terms of a person who is good in the training and also good in the testing. That's what the difference between general, you can say, the first hand always in the training very good, but the testing bad. A person who is good in the training and also good in the testing, that's what in the machine learning we need to find out that kind of person or that kind of algorithm. And in that case, to get such kind of model, this regularization terms are very, very important. These regulations are helpful in getting or making the machine learning model more generalized. More generalized means performance will be better in the training and testing as well. What do you mean by training and testing, and what kind of different kind of this regularization we can put either in layman, you can say L2 or L1, different, those who are familiar are available for machine learning, are also so many others. So this one is also important part in every machine learning models. What is happening, just see the picture and how this regularization is helping to get the better result. There are two kinds. If in the machine learning models you train and test, what we do always two kind of things. Sometimes you just see this regression method. Here I want to put a regression. I'm talking about the training. Just see the training, what is happening. This method, is it a good regression for this data set? No, many are not satisfied. In this case, very good, many are satisfied. In this case, most of them are satisfied. What is the difference? This one is a simple line. This one is too rigid. Training is so perfect, almost you can say everything is satisfied. It becomes the disadvantage that too much overfitting, it becomes overfit, spoon fit model. High variance will be there. Training error is much lower than the testing error. What it means? Training is very good. Performance 100%, 99% accuracy in the training. Because too much trained, everything is perfectly classified except one or two. But the testing case, in most of the time, you put the outlier kind of things, performance will be degraded. Because too much has been trained. This is the case of overfitting. And underfitting, very less trained. So in the terms of machine learning, training and testing are two scenarios. If the training performance is very high and testing performance is poor, this one is the example of overfitting. And if training is low like this, and then if not trained anyone, then chances are high that the testing will be random. Sometime good, sometime bad. But overall performance, you will see that testing will also be poor. This is the case of underfit. We want to make the balance, and to get this balance kind of learning, these regularizations are helpful tool in the way or philosophy, you can say, in the different algorithms. And regularizations are applied in the different algorithms in a different manner. Not necessarily same thing we can apply in the deep learning another. A different approaches, either drop out and others are there, which will be taken in the next half. Same way you can see the classification, what will happen. Underfit and overfit, and this is the best case. See this case, simple line. And this one is the case. In this case, the error are less. Even though in this case, error are high. But just putting a line is not enough. This is the case of underfit. But in this case, you just see beautifully each and everything is correctly classified. Okay. This is the example of zero error, 100% accuracy in this case during the training. But chances are high that during the testing, this one is going to perform poorly. This one is going to perform. What next if new data is coming? How this pattern will behave, zigzagness. So performance during the testing will be poor in overfit case. But in underfit case, too simple. Using regularization, we will make this, where the training also have some error, but the testing better chances are that better performance will be better in the compared to underfit and overfit. So the whole, even though those who are using the toolbox, this regularization and analysis of overfitting and underfitting are necessary to get tuned up your models to perform better in your particular application. So that the whole idea is to make the balance of the learning between underfit and overfit. Too simple model, if you change a simple plane, for the sake of simplicity, just come to the previous. This is the plane equation, straight line you can say. And this one is the equation of higher polynomial of 10th degree, you can say. But this one is a quadratic parabola. So if you want to make a regression, straight line ax equal to b is sufficient, or ax square plus bx is sufficient, or ax cube plus bx is sufficient, or ax to the power 10 plus bx to the power 9 is sufficient. Which kind of curve is sufficient or better for your data sets? Who will tell you that? And so it's again a challenging problem to get that best way. So regularization, what is that? Also, if you start with this, you will regularize. So what after the regularization, different kind of regularization, some feature will be discarded, means no important at all. So regularization from any starting point, even for the 10th degree polynomial, if you start, regularization will help you to get this one or somehow closer to this one kind of structure. So the main idea is too biased, that too simple kind of learning, or too variance means too much fluctuation in the performance of the model. So variance is high or bias is high. So we had to make the balance between two. Underfit or overfit, you can say, we had to make a balance in the whole each and every machine learning models. Okay, so quickly next 10 minutes I will talk about what is the role of hyperparameter and model design. Anyone who are going to use, what you have to see that. In support vector machine, I have discussed about the hyperparameter ESC. In ANN, I say that the hyperparameters are like number of hidden units, number of nodes on each hidden units. You have to predefine, because the methods performance are also going to be based. If you change the number of hidden layer and change the number of nodes, performance of the whole algorithm may change, because algorithms are going to learn the weights of the parameter W1, not the hyperparameter. Hyperparameter, either through empirical study you have to put, or through expert knowledge. Okay, this much hidden layers, this much node at each hidden layer. Once you put, your network will be ready, and that network through the gradient descent and all minimize the error function, and it will learn the weights. So hyperparameters you choose, then model design, how many layers, activation, which kind of activation, and what is the any variables are there. If that variables you have to fix. And then combined with, if you use the optimization problem, those who are aware, a lot of hyperparameters comes out, learning rate in that case also. And then also then finally based on the model design and hyperparameters, finally the model parameters we learn. That's what the nutshell in the machine learning application whenever you are going to do the real world. So what we do in the training and test is, again, this part I will quickly summarize how we apply the machine learning models. We have our original data sets. We split data sets, training and testing. Most of the time, 70-80% for training, and this one is the testing part. This part, testing part, no way we are going to use during the training. This is unseen for model during the training. And then we in the training also we can split, or sometimes we may not, many are not, training and validation. So this part we are not choosing. This is the testing. Within the training, what happened? There are many kind of either whole data at a time for training, or 10. For some part, you can keep the validation. You can say that 10% for the validation. Do the training and do the validation. If validation is performed, again, retune your hyperparameters and all, and see that what is happening. So you do this machine learning training. Once you say that model is trained, go for the testing and see the performance of the model. So this way, there are k-fold validation or single, or which technique you are going to apply that. That's a different application way of doing that. But this one is very, very important. And this testing and training split should be the random way. And so that somehow, and then you have to repeat this one, basically that in the k-fold and all, this model testing and training just repeat many times. So that average behavior you can see of your model, how this average way they are going to work in the general data sets. So divide, test, and validate. This is the important part in the machine learning. This part will be helpful basically to tune up hyperparameters and all, so up to certain extent. And then this part, once you learn, is it your learn model is performing well or not? If not, again, you have to tune up your model and see that. Tune up your model means you cannot tune the weight. You can only change the hyperparameters, and then you have to learn and see that which one is getting to perform in the better way. So for the designing purpose, just how to apply even in the IoT application, you have how you are going to choose these models. The important part is choose a training experience. What kind of work you want to do? That is important. The target should be known. Choose exactly what is to be learned. Target function, what you want to do, that classification, regression, that you have to look at the application and clearly mention that this one is my job and I want to be done by the machine learning models. Then you have to look at how to choose representation, a target function, like a support vector machine kind of structure, or NN kind of structure, or logistic regression. And then choose the learning algorithm to infer the target function from the experience. And then already I told that training versus test distribution. IID is independent and identically distributed assumption. Most of the time, we assume that most of our data set is coming with the same kind of from the same kind of distribution. This assumption, or also the obvious behavior of data sets like that, help us to make a better machine learning algorithm. So this, if the data sets are the different, time will come, your machine learning performance will be poor in that case. The data sets distributions are different. So if the assumption is, if the IID independently and identical kind of distribution of the data sets or the signals or noise are coming at the same kind of, then the learning will be better in that case. If examples are not independent, requires some classic. If not independent, then the joint distribution means the generative kind of models. Then we have to put this. Discriminative models may not be helpful. Generative means whole distribution or data science pattern that we have to learn. Also, there are methods like the different kind of distribution of data sets from one distribution data sets to other kind of distribution data sets. Transfer learning concepts are also available to adopt same model from one domain to other domain. There are different kind of philosophies are for that is available in which you may apply. So what finally in the nutshell in the machine learning models is thousands of machine learning algorithms and hundreds new every year people are proposing and modifying in ANN, SVM, this and that. So what three things common in each and every machine learning or deep learning models are? First thing is that representation. What it means, how to represent the data sets. 10 dimension, 20 dimension, what are the features? All these are very, very important to use SVM, ANN, in ANN, 3 hidden layer, 20 hidden layer, each one 20 nodes, 50 nodes, all are comes out under the representation learning. You change the structure, representation will be different, your learning may be different. So the first thing is that in every machine learning and learning algorithms are representation. Once you represent that, the next thing comes out optimization technique. Most of the models we are going to optimize. Some error function, some major function we define, and we try to measure that through optimization. And this optimization process basically help us to learn the weights of our models which we have designed. And once we have this, we need the third part in evaluation. How to evaluate that whatever has been learned is good or not. Various function representation are either already so many names I already have discussed. Either linear regression, ANN, SVM, decision tree, nearest neighbor, so many algorithms. I cannot say. Either probabilistic graphical model, neo-Bayes, Bayesian network, hidden Markov model, Markov network. So many different methods of this are available for this purpose. Even for the optimization, if you go gradient descent, most famous stochastic gradient, ADA grade, so many techniques which you can apply. Dynamic programming for HMM and learning. For decision tree, most of the time we use divide and conquer. Many people have experimented with genetic algorithm and other evolutionary algorithms for the optimization. But most of the 99% you can say it is gradient descent, stochastic gradient descent, ADAM, or the variants of those are fast enough, quickly giving the better results compared to the other method. For the evaluation, every time we had to think about either we are going to see in a different application, precision, recall, square error, entropy, or KL divergence. If you measure the distribution similarity, in that case, KL divergence comes out. Square error likelihood comes out. Square error already we have seen in the support vector machine and also in ANN. Posteriori probability and cost utility. So what the point is that you have to define the evaluation metric. What is the metric which will be see the evaluation that or measurement to say that our learning is happening in the proper direction, to measure that okay, this one is the new way, so learning is good or bad. So machine learning is that learning experience, through the experience this learning we want to improve. So for getting this learning, one measure is required, and that measure for the different model are different kind of measures are which we can use. At the end, though just I am connecting and stopping here, what is the machine learning, and then what the deep learning is coming, which is going to be covered in the next session with you. Just the difference between this. What I told that in the machine learning part, we need an input and then we need a feature engineering techniques. And feature engineering techniques are required so that either PCA, ICA, or another kind of feature, so that our classification SVM or ANN perform better. If the feature extractor is performing poor, of course, this model is going to perform poor. But in the whole machine learning era, you can see that the huge application of this extractor was there. Later on, people thought that, okay, this is the case. This feature extractor is highly going to influence the performance as well as the model. Can we think about the feature extractor? And that's what the invent of deep learning, you can see that. Can this feature extraction also be captured in the network? Give the raw data and get the output. Instead of feature extractor expert, put it this feature engineering also in the network. or in the automation of the model itself, representation itself. And that's what is happening in the deep learning model. This feature engineering has been, you can say, just clubbed in the network itself. And this one is the deep learning. More detail, this deep learning part in the next session, Professor Sekhar Verma will cover with some IoT application. With this, I would like to end here, and I will be happy to take questions from your side if you have. Thank you.